Hello and welcome to this last video. We'll see some new features, new elaboration that we can perform over digital elevation model. Let's start about our digital elevation model in the EPSG 23032. And let's suppose that we have a path, and here it is. And with this path, we want to define the profile. We go as we have seen before on this and click on profile. Here it is. We just define which is the digital elevation model, the profile route, if we want to use or not use the interpolation, where we want to save the file, and we have the result. And we see that this profile we can, with the right click, save as PNG, print directly, see the properties when we can define the title, the plot, and other aspect. As well, we can modify the zoom in, both axes or just one of the two. And you see that here you see the distance, and here the elevation changes. In this case, it's a path going from the hill to the sea. So this is the let's say the line, the trend. Let's do some more elaboration. Then we have maybe some cities, and we want to see which part are visible from one city, from one point, which part of the land. So we have to calculate the coordinates, and we have already insert the coordinates. Then we go on again on our tool, and we go about searching visibility. Here it is, double click, and here we define, okay, which is the digital elevation model, which method we want to use. We have two main methods, distance and visibility. With visibility, you only define which pixels are visible and which one are not. With distance, you add also the distance from the analyzed point. Then you enter x and y of the point, then the height of emitter or receiver, the height of receiver in this case, and the radius, because maybe you can define how long you can see what is the distance then as before the output region, and we go for OK. And the result, I've already prepared for me to speed up everything, is this one. You see, in this case, you have the distance from this point, from these cities, and given 2.5 thousand meters. And you see that here I have some pixels in the sea that I don't like so much to be seen. So I can introduce a new tool that is the masking. And here I have the, let's say, the shapefile of the boundary of the ebb isle. I can rasterize. We have seen how to rasterize, but in this case I can rasterize to produce a map. So here if I click on mask, rasterize vector layer for mask, they just ask which is the shapefile to be rasterized for a mask, and the result is this one. I have, you see, in let's move the other. I have a 01 file, and that if you just have a look in the information, I have 0 outside and 1 inside. So what I can do now is to multiply the Elba mask, multiply the distance. You remember what it is. Here it is. And I expect to be removed the part in the sea. So the multiplication we have already seen, it's just through calculator and just enter your parameters. Sorry, as a calculator. Here visual distance, multiply Elba mask. And the result is this one. And you see that the mask, you see the visibility, here it is, has been masked. Let's say that the part in the sea is not visible anymore. So here you see you have these values, and if you click on this with the information, you will see that you have the visibility distance from the analyzed point. Let's go on analyzing other possibility of working with the digital elevation model. Let's suppose I have a protected area to be protected from several aspects for to be visible, and I have to rasterize as well. Remember that to rasterize a vector layer, you need to have let's say a field, numeric field. I have just inserted this to be possible to rasterization. Then I rasterized, and this is my result. You see, I have a raster derived from the protected area. So now I want to introduce two concepts about the visual exposure, collect values, or irradiate. The visual exposure, collect values, let's say, provides the information from how many points in the digital elevation model or portion of it a given element is visible, and it's needed the creation as well of a constant raster layer obtained through the algorithm constant grid. I will show how it works, that the constant grid can be created from this constant grid. I just create it, so I have created as well. And now I want to see, let's say, how many pixels are visible from outside area of protected area. So I just launch visual exposure, here it is, and I have, as I told before, irradiate or collect values. Let's analyze collect values. I define just the radius because I cannot see, let's say, everywhere. So I define a limit of distance, and this is the result. You see, if I zoom, I see that from outside, I see that, for example, this pixel is visible for 446 points of my digital elevation model. So it gives you the idea of visibility from outside of internal pixel. There is another difference, that is the irradiate, that provides you the information. You see, this is the, to make you visible, this is the protected area. You see, it is inside, and through the irradiate you receive the information of how many pixels of the protected area is visible from a given point. So let's say if I click on this one, I see that 427 points of the protected area are visible from this point, and so on, 421 and this one. So it gives you an idea of the location from where you see the most or the last point of the protected area. I hope you have enjoyed also this tutorial about DEM, and thank you so much for having attended this webinar. Thank you.